control charts. So our objective for this video is we want to define a control chart. And this is more of an informational video. We'll get into a little bit of mathematics on the next video when we talk about our control charts. Let's begin by defining statistical process control, abbreviated SPC. Statistical process control is a method of quality control which employs statistical methods to monitor and control a process to maintain and improve product quality. So anyone who is producing something will be doing this to make sure that the quality of whatever they're producing is consistent. And what they do is they take samples that are tested during a production at specified intervals to determine whether the production process needs adjustment to meet quality requirements. Okay, and the process, what you'll find from these samples and the various charts you can make is the process in control or is the process out of control? Okay, so the production process is considered in control. In other words, it's considered statistically stable. This is a good thing. We want whatever we're producing to be consistently stable, to be very, almost always the same as we produce it. Envision producing shoes, for example. Size 10 shoes. Well, they're not going to be perfectly the same, but as long as they're consistently the same within a specified range, we feel good about it, or the producer feels good about it. So in control, if it is stable and predictable, and sample measures fall within upper and lower control limits, abbreviated UCL and LCL. Again, take a size 10 shoe. Okay, to get every shoe to be exactly, when you measure it to, let's say, the 100th or the 1000th of a unit, to get them to all be exactly the same is impossible. But you can say we want them to be the same within, let's say, a 100th of an inch in either direction, for example. In that case, we'll call these shoes size 10 as long as they fall within a 100th of an inch in either direction. As I mentioned, the other possibility, a production process is considered out of control. It's statistically unstable. If it has an unpredictable amount of variation, an unpredictable spread, and there are sample measurements outside the control limits. Okay, go back to our shoe example. If shoes are coming out that are a half inch different than your ideal size 10, you may, that's obviously too much. That's not a size 10, and we want to have, when that happens, we want to recognize that something is unstable. So we use control charts, and there are a variety of control charts that are used. We're going to look at one specifically in the next video. A control chart is a line graph used to show a trend of a production characteristic over time. Again, in my example, the shoe size. The center line is the determined mean, which ideally is the equivalent of the population mean, mu. Very rarely will you be using the population mean, but ideally, the mean would be the mean of all the shoes you produce. The center line would be the mean of all the shoes you produce. And you have upper and lower control limits above and below the center line, established by the use of a formula or a table. So here is a generic control chart. You can see we've got here down the hour of production. So at hour 1, we took a sample. At hour 2, we took a sample. And here is our center line. Ideally, this is the population mean, the average of the population, the average size of the shoe, for example. and we have an upper limit and a lower limit of what's acceptable that we're looking at. And obviously you want to have our shoe sizes, as my example, to be within these limits as they're made to be qualified as a size 10. Okay, and over here we notice that this is a normal distribution. Here's our normal distribution curve laying on its side, and we're looking in this case we're at 3 standard deviations above and below, because it tells us that we're at 99.7% of our measurements. Now you can see here in this case that we do have one at hour 14. We took a sample and it was below the lower limit, and so this is out of control because we want to have it within the limits. Excuse me. So we want to look, the person in charge wants to see what's going on with this particular process. So there you have it, some basic information about control charts. In the next video we're going to talk about our control charts. Excuse me, yes, our control charts.